Hello, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. You're listening to Season 5, Episode 50.
That's right, Episode 50. Half a century of episodes this season alone. Thank you, honestly, to every single listener who's been on this journey with us.
It's been an incredible ride, and today we have 6 stories that are absolutely worthy of the occasion. We're talking a star that may be dying in real time, a skull-shaped nebula revealed by the James Webb Space Telescope, a dragon capsule splashing down this morning, a blood moon just days away, fresh evidence for life in the Jupiter system, and a major shakeup at NASA following one of the most damning reports in the agency's recent history.
Big show. Let's get into it.
We're starting today with one of the most dramatic stories in stellar astronomy in recent memory. Avery here. Picture a star so enormous that if you placed it at the center of our solar system, its outer edge would reach beyond the orbit of Jupiter. That's WOHG 64, and it may be dying right before our eyes.
WOHG 64 has been known to astronomers since the 1970s. It lives in the Large Magellanic Cloud, a dwarf galaxy that orbits our Milky Way, about 160,000 light-years away. And for decades, it was classified as the most extreme red supergiant in that galaxy. We're talking a radius of roughly 1,540 times that of our Sun. That is almost incomprehensibly large.
But here's where it gets really interesting. Back in 2014, astronomers started noticing something was changing. The star began to look different, its color was shifting, and its surface temperature was rising. A team led by Gonzalo Muñoz Sanchez at the National Observatory of Athens has now published research in the journal Nature Astronomy, confirming what they believe is happening. WOHG 64 has transitioned from a red supergiant into something far rarer, a yellow hypergiant.
Now, yellow hypergiants are extraordinarily rare. Why? Because they represent a very brief, unstable transitional phase. Muñoz Sanchez described them as a short-lived bridge between the red supergiant stage and the eventual supernova explosion. There are only a few tens of confirmed yellow hypergiants known to us in the entire universe. So to potentially be watching one form in real time is remarkable.
The transformation appears to have happened relatively quickly on a cosmic timescale. The star essentially shifted from red to yellow in roughly a year. What drives this? Strong stellar winds, powerful enough to strip away the outer layers of material the star has previously shed. That process heats the star up and reveals a hotter, smaller surface beneath. It's like peeling back the layers of a cosmic onion.
There's an added twist to this story, though. The team also found evidence that WOHG 64 isn't alone. It appears to have a companion star. And that binary relationship may be complicating the picture considerably. If a companion is stripping material away from the main star through gravitational interaction, that could explain some of what we're seeing independently of the supernova pathway.
In fact, there's some scientific debate here worth noting. Another team, led by Jaco van Loon at Kiel University, observed WOHG 64 more recently and found signatures suggesting the star's atmosphere might still be that of a red supergiant. They're being more cautious about calling this a confirmed transition, so the jury, at least partially, is still out.
But what everyone agrees on, including the skeptics, is that something extraordinary is happening with this star. As Van Loon himself said, we are all witnessing an unprecedented spectacle. Whether WOHG 64 ultimately explodes as a supernova, collapses directly into a black hole, or merges with its companion, we are watching one of the universe's most massive stars navigate the final chapters of its life.
And that's something we may literally get to see, a supernova from a well-documented, well-studied star, if and when it goes. It would be a scientific gift of the highest order.
Staying closer to home now, well, closer than 160,000 light-years anyway. Yesterday, SpaceX's CRS-33 Dragon cargo capsule undocked from the International Space Station, wrapping up what has been a genuinely historic 6-month stay.
CRS-33, that's the 33rd commercial resupply services mission SpaceX has performed for NASA, arrived at the station back on August 25th last year. It delivered around 5,000 pounds of supplies and scientific equipment. But what really sets this mission apart is something that happened during its time docked.
For the very first time, a Dragon cargo capsule was used to reboost the orbit of the space station itself. The station sits in low Earth orbit, and atmospheric drag, even at that altitude, gradually pulls it lower over time. Historically, Russian Progress spacecraft and the station's own thrusters have handled the job of pushing it back up. But Dragon introduced a brand new independent reboost capability during CRS-33.
It performed 6 of these reboosts during its stay, 5 in 2025 and a final one in January. That might sound like a technical footnote, but it's actually strategically significant. As the geopolitical landscape around US-Russia space cooperation continues to evolve, having an American spacecraft capable of maintaining the station's orbit is a real capability milestone.
The capsule undocked at just after noon Eastern Time yesterday, February 26th. It was scheduled to splash down in the Pacific Ocean off the California coast in the early hours of this morning. NASA wasn't streaming that splashdown, but updates have been posted to their station blog.
And Dragon wasn't just heading home empty-handed either. It's bringing back a packed cargo of scientific results, including samples from the Euro Material Aging Study, which spent a full year exposing 141 different samples to the harsh environment of space to see how insulation, coatings, and 3D printed materials degrade. Plus results from Thailand's liquid crystals experiment looking at how materials used in displays behave in microgravity.
What this mission really demonstrates is how far SpaceX's role has evolved. They're no longer just a delivery service for the station. They're now actively helping to maintain and sustain it. That's a significant evolution in the commercial spaceflight relationship.
Now for something that's going to stick in your imagination, I promise. This week, NASA released stunning new images from the James Webb Space Telescope, and they might be the most striking thing Webb has produced this year. Ladies and gentlemen, meet the exposed cranium nebula.
I love that name, and the images absolutely justify it. Officially called PMR1, named after the astronomers Parker, Morgan, and Russell, who discovered it in a sky survey in the late 1990s, this nebula surrounds a dying star and looks almost uncannily like a transparent human skull with a brain visible inside it.
The nebula was first observed in infrared light by the now-retired Spitzer telescope back in 2013, which is when it got its nickname. But Spitzer's view was relatively indistinct. Webb has now looked at PMR1 with 2 of its most powerful instruments, NIRCam, the near-infrared camera, and MERI, the mid-infrared instrument. And the difference is extraordinary.
In the near-infrared image, you can clearly see an outer shell of gas. This is the skull, composed mostly of hydrogen blown off by the star in an earlier phase of its death. Inside that, there are 2 hemispheres of complex ionized gas forming the brain, and running vertically through the center is a dark lane, a gap that divides the 2 lobes and gives the nebula its distinctly cerebral appearance.
The mid-infrared image from MERI tells a different story. Warmer dust and denser material glow more prominently, and you can see evidence of gas being actively pushed outward from the central star through what may be polar jets. That dark central lane appears to be related to outflows or jets from the star firing material out in opposite directions, top and bottom.
What's particularly intriguing is how much scientists still don't know about this object. The mass of the dying central star hasn't been precisely determined yet, and that matters enormously for predicting its fate. If it's sufficiently massive, it could explode as a supernova when the end comes. But if it's a lower mass star, more like our sun, it will keep shedding its outer layers until only its dense, cooling core remains, a white dwarf.
There's also speculation that PMR1 central star could be a Wolf Riot star, an especially hot and luminous type of star known for ferocious stellar winds. That would explain the dramatic outflows and layered structure we're seeing.
Either way, what Webb has delivered here is a masterclass in the death of a star. Every one of these images is a reminder of why we built this telescope and what it continues to reveal about the universe around us. I highly recommend looking up those images. They are genuinely breathtaking.
All right, Skywatchers, this one is for you, and the timing is brilliant because you've got just 4 days to prepare. This Tuesday, March 3rd, the moon is going to turn blood red in a total lunar eclipse, and it's the last one of its kind visible until the very end of 2028.
Let's explain what's happening. A total lunar eclipse occurs when the Earth passes directly between the sun and the moon, casting our planet's full shadow, called the umbra, across the lunar surface. The moon doesn't go dark entirely, though. What happens instead is that the only light reaching the moon is filtered through Earth's atmosphere, and Earth's atmosphere scatters away the blue wavelengths of light, allowing only the reds and oranges through. The results? The moon turns that spectacular deep coppery red that gives it the blood moon nickname.
Totality, the period when the moon is fully within Earth's shadow, will last 58 minutes, from just after 11 a.m. UTC to just after 12 p.m. UTC on March 3rd. Maximum eclipse, when the moon sits deepest in the shadow, occurs at 11:33 UTC.
Now, visibility depends heavily on where you are in the world. The best seats in the house are in the western half of North America, Hawaii, Australia, New Zealand, and across the Pacific. Eastern Asia will also get a great view of the eclipse in their evening hours. Observers in much of South America and Central Asia will see a partial eclipse. And unfortunately, if you're in Europe or Africa, this one is going to pass you by entirely. The moon will be below the horizon for most of the event.
There's a lovely bonus for North American observers in particular. During the eclipse, as the full moon dims significantly, fainter objects in the sky become much more visible than they normally would during a full moon. And there's actually a rare event happening during totality. The moon will occult, or pass in front of, the galaxy NGC 3423, which should be a treat for telescope users.
No special equipment needed for the eclipse itself. This is one of those events you can simply step outside and enjoy with the naked eye. Unlike a solar eclipse, you don't need any filters or protective glasses. Just find a dark spot, look up, and watch our cosmic companion transform.
We'll have a reminder and more observing tips in our episode on Monday, but mark Tuesday, March 3rd in your diary now. Set your alarm, get outside, and enjoy the show. Next chance for another total lunar eclipse after this? New Year's Eve 2028 going into 2029. So this really is one not to miss.
Now for a story that could reshape how we think about the origin of life in our solar system, and perhaps beyond it. Astronomers and astrobiologists have long been fascinated by Jupiter's icy moons, Europa, Ganymede, and Callisto in particular, because they harbor vast liquid water oceans beneath their frozen surfaces. And where there's liquid water, there's potential for life. But new research published this week suggests those moons may have been even better prepared for life than we previously thought.
An international team, including scientists from the Southwest Research Institute and Aix-Marseille University, have published 2 complementary studies, one in the Planetary Science Journal and one in the monthly notices of the Royal Astronomical Society, that model how complex organic molecules formed and were delivered to Jupiter's moons at the very moment they were born.
Complex organic molecules, or COMs, are carbon-rich compounds that also contain elements like oxygen and nitrogen. On Earth, they're essential precursors to life. Think amino acids, proteins, the building blocks of DNA. And the question the team was asking was, could these molecules have formed in the early solar system, around Jupiter specifically, and ended up embedded in the Galilean moons during their formation billions of years ago?
The answer, according to their models, appears to be yes. When icy dust grains containing simple compounds like methanol or ammonia were subjected to ultraviolet radiation and moderate heating, conditions that existed in both the wider disk around the young sun and in Jupiter's own circumplanetary disk, complex organic chemistry could occur. The resulting organic molecules were then transported by those icy grains into the growing moons as they formed.
Perhaps most strikingly, their models show that in some scenarios, nearly half of the simulated icy particles carried newly formed organic molecules from the solar disk into Jupiter's local environment without being destroyed. Lead author Dr. Olivier Moussis put it clearly: Jupiter's moons did not form as chemically pristine worlds. They may have accumulated a significant inventory of these complex organic molecules right from birth.
For Europa in particular, this is exciting. Europa is already considered one of the best candidates for life in the solar system, with its subsurface ocean in direct contact with a rocky seafloor, conditions not unlike Earth's deep-sea hydrothermal vents, where life thrives in total darkness. If that ocean also began with a supply of organic building blocks, the case for habitability gets considerably stronger.
The researchers also note that this finding has implications for NASA's Europa Clipper mission and ESA's JUICE mission, both currently en route to Jupiter's system. These missions carry instruments capable of detecting organic molecules, and this new research gives scientists a framework for interpreting whatever they find when they get there.
It's worth stepping back and appreciating what this research is telling us more broadly. The ingredients for life may not be rare or special. They may be woven into the very process of planetary formation, delivered as standard across our solar system and, by extension, potentially across the universe. Every time we think life requires a lucky break, a study like this suggests the dice may be loaded in life's favor.
And we close today's episode with a story that's been building for over a year and finally came to a head yesterday. NASA has replaced two of its most senior human spaceflight leaders, just 1 week after releasing what can only be described as a devastating internal report on the Boeing Starliner crew flight test.
For listeners who may have missed our earlier coverage of the Boeing Starliner saga, here's the quick version. In June 2024, NASA astronauts Butch Wilmore and Suni Williams launched on Boeing's Starliner spacecraft for what was supposed to be an 8-day test mission. But once docked at the space station, multiple thruster failures and helium leaks in the propulsion system emerged. After weeks of analysis, NASA made the call that Starliner was not safe enough to bring the crew home. They came back in March 2025 on a SpaceX Crew Dragon, after spending 286 days in orbit instead of 8.
Last week, NASA Administrator Jared Isaacman held a press conference to announce the findings of an independent investigation into what went wrong. The conclusions were stark. The crew flight test has been retroactively reclassified as a Type A mishap, NASA's highest severity classification, previously reserved for events like the Space Shuttle Challenger and Columbia disasters. That classification simply means damage exceeded a $2 million threshold, but the symbolism is significant.
More damning still were Isaacman's words about what the investigation actually found. And I want to quote this because it really cuts to the heart of the matter. He said, "The most troubling failure revealed by this investigation is not hardware. It is decision-making and leadership that, if left unchecked, could create a culture incompatible with human spaceflight."
Strong words. And yesterday, action followed. NASA announced that Ken Bowersox, the Associate Administrator for the Space Operations Mission Directorate, is retiring with his last day on March 6th. Steve Steisch, the Program Manager of the Commercial Crew Program, has also been moved from that role. Their deputies, Joel Montalbano and Dana Hutcherson, have stepped in as acting leaders of those programs with immediate effect.
Now, it's worth being precise here. Bowersox's retirement was announced the day before and appears to be a genuine retirement rather than being pushed out, though the timing is impossible to ignore. And Isaacman notably did not publicly connect the leadership changes to the Starliner report, though he had explicitly promised accountability would follow. Reading the room, most observers see the connection as clear.
Where does this leave Boeing Starliner? It won't fly with crew again until technical causes are fully understood, the propulsion system is qualified, and investigation recommendations are implemented. An uncrewed cargo mission is still on the calendar for no earlier than April. And NASA says it remains committed to having 2 commercial crew providers, the redundancy principle that drove the Starliner program in the first place.
But there are real questions about the program's future beyond that. The ISS is due to be decommissioned in the next few years. Starliner's contracted rotational missions have already been reduced. And with SpaceX's Crew Dragon operating reliably, the urgency of getting Starliner certified for crewed flight feels somewhat diminished from NASA's perspective.
What this episode ultimately speaks to, I think, is the culture of human spaceflight. The Challenger and Columbia disasters both had technical causes, but both also had cultural and organizational failures that allowed problems to be minimized or ignored. The fact that the Starliner report uses that same language, decision-making, leadership culture, is a warning that the lessons of those tragedies need to be continuously relearned.
We'll continue to follow the story closely, and we'll have more on Starliner's path forward as details emerge in the coming weeks.
And that is our episode 50 of Season 5 of Astronomy Daily. What a show it's been. A dying hypergiant, a dragon splashdown, a cosmic skull, a blood moon, life's building blocks around Jupiter, and NASA reckoning with its own culture. The universe, as always, delivers.
If you enjoyed today's episode, please take a moment to leave us a review wherever you listen. It makes a huge difference in helping new listeners find us. And follow us on social media at Astro Daily Pod for daily space shorts and news updates.
And if you haven't already, head over to astronomydaily.io for full show notes, our blog posts, and all our back episodes. We've got 50 of them this season alone for you to explore.
We'll be back on the weekend with more space and astronomy news. Until then, keep looking up.
Clear skies, everyone.
Astronomy.